Alright. Not typo, I think this one, this one, no. This one is very far away, right? This label, can you make sure that this label here, this one is actually this length? Okay, it's very far down for you all. This one is just this length. Okay, can? I do write this printed correctly for you all. Correct? Okay, let's carry on. Sorry, I'm a bit dry and the aircon is. Yeah, never mind. The school is breaking down. No. I always say, can you all, after you all graduate, you all earn a bit more money, donate some aircon to school, can? Or make the life of teachers a bit better. Can, Ryan? What did I say? What did I say? Don't know, right? Talk rubbish, you also cannot listen. Then let alone talk about differentiation. Okay, next. We want to learn how to differentiate inverse trigo functions. Now, okay, pause. End result, we want to know this. That means differentiate sine inverse x is this. Now, that's my objective. What happens before this is the proof. You want to know proof? You want to know proof? Yes, very good. Let's do the proof. But can you promise me that yours don't talk? Thank you. If not, I'll just skip. Okay, you all can accept the result, which is this. But I think that's not the way. I think it's better to know. Okay, let's do this. End objective is, we have this. I want to prove this. That means differentiate sine inverse, I get this. But how do we do this? Now, if I rewrite this, if y is sine inverse x, then sine y is x. This one no big deal. That's what we all know. Now, if sine y is x, can I draw a right angled triangle? Y is the angle, x is the opposite, 1 is the hypotenuse. All agree? If sine y is x, sine y is x over 1. Alright? Also far good. Now, if you have this right angle triangle, do you all agree that if this hypotenuse is 1, this is x, this is square root, what is that, 7 here? What's 7 doing there? Do you have 7 in your notes? Have or not? Don't have, right? Okay, then shouldn't have. This must be square root 1 square minus x squared. So what's good? Okay, now we are done. Do we know how to differentiate this implicitly? Okay? Differentiate sine y, you get cosine y dy dx equals to 1. Dy dx is 1 over cosine y, no problem, divide both sides. What is cosine y? Cosine y is adjacent over hypotenuse, which is this. So now we have shown that dy dx is actually this, because y is sine inverse x. Am I going through too fast? All okay? Okay. If you only understood 60% of what I just said, don't worry. End result is important. More important, you need to know differentiate. Sine inverse is actually this result. The next question is, do you need to memorize? Did I start recording? Yes, I did. Do you need to memorize? No. Answer is it can be found in MF26. Where is MF26? Let me show you. Where exactly is it found? Here. Can you have attention, please? Yo, so big, goodness. Like that. Okay, differentiate this, you get this. Do you need to remember? No, you don't have to. I do not intend to go through. All these can be found, can be shown. And all this using chain rule. I'm going to pause here for 20 seconds. Make sure you understand this page, this chain rule bit. Okay? Talk to the friend next to you, make sure you understand. Pause. 20 seconds. This one, me and your tutors will keep emphasizing this, but still there are people who make this mistake. Can you have attention? Thank you. Sine inverse x is not sine x to the power of minus 1. Sine x to the power of minus 1 is 1 over sine, which is cosecant. This one just means the angle. That means if y equals to sine inverse x, it just means that sine y equals to x. So that means y is an angle. Y is an angle, x is a ratio. Can I have attention, please? Thank you. One more time. If this means that this sine y is x, it means y is an angle, x is a ratio. If x is a ratio, does it make sense then that x must fall between minus 1 and 1? No, it doesn't make sense. Some of you shake head. One more time. You all look at this. Why must x fall between minus 1 and 1? Because x is a ratio. X is a ratio. X is a ratio between this opposite side and the hypotenuse. X cannot be larger than 1. Does it make sense? X is a ratio. So, x must fall between minus 1 and 1. Similarly for cosine, but not for tangent. Follow? Can? Okay. I tell you also cannot register. Never mind, we'll do the example. Easier. Example 16. We start out, what's the big deal? Okay, come. Example 16. Can I have attention, please? Thank you. You all so clever, you all do lah. Huh? Want to do on your own or not? Huh, Rangi? Want to do on your own or not? No lah, I just ask you a question. Why you give me innocent look also? Yes, carry on. We want to differentiate tangent inverse 5x squared. Now, look up. Either you do on your own and keep quiet, or you look up and listen. Two options. Now, you look at formula list. Differentiate tangent inverse, you get this. But now this is only x. You have to apply chain rule, can? So you are required to differentiate tangent inverse 5x squared. So does it make sense that you must have a 1 over 1 plus 5x squared? And this one, you must be able to see. That's not all. You have to apply chain rule and you have to differentiate 5x squared. What do you get from differentiating 5x squared? You get 10x. So that's why you have a 10x here divided by this. You all follow? All got that? Good. D. You are supposed to differentiate cosine inverse sine 2x. Again, I look at formula list. Differentiating cosine inverse, you will get this. Can? Differentiate cosine inverse x, you get this. So, you will get a negative 1 over square roots 1 minus this whole thing square. Correct? You will get a sine 2x whole thing square. But that's not all. You have to multiply by a, using chain rule, you must multiply by a differential of sine 2x. Don't forget this. Some of us may, in the haste of doing everything, you forget this because this is already complicated enough. Yes? Differentiate sine 2x. What do you get? You get negative. Differentiate sine 2x. You get a 2 cosine 2x. Don't forget your 2. And usually when we write this sine 2x whole thing square, we put a square here. Now, not done yet. From here to here, no big deal. You get 1 minus sine square, you get cosine square. Now, square root of cosine square 2x. By right, you should get a mod 2x. By right, recall, recall square root of a square actually is mod a, not just a. Okay, you all recall? Yes? Now, therefore, recall square root of a square is just a mod a. You get this. You by right, you should get a mod. Now, there must be a reason why the question was quite clear. X must fall between minus pi over 4 and pi over 2. So now we take a look. If x is between pi over 4 and pi over 2, 2x must be greater than pi over 2. Or rather, actually I rewrite it like that. If you, that means 2x must lie between pi over 2 and pi. Now, between pi over 2 and pi, you take a cosine of pi, between pi over 2 and pi, you will definitely get a positive number. No, wrong. You will definitely get a negative number. Why? Your cosine graph looks like this, you know. If you take a cosine of any angle between pi over 2 and pi, you will get a negative number. So this cosine 2x between pi over 2 and pi, take cosine, you will get a negative number. So therefore, mod cosine 2x is actually negative cosine 2x. Do you follow? Follow, don't follow. Therefore, you can get an answer of 2. I think some of us are confused. Are you confused? The important thing is, do you know how to get from here to here? How do you get from this line to this line? The reason is very simple, because cosine 2x is negative is here. You copy this graph and you will go back and digest here. Okay? Okay, we've got to move on, sorry. 16C. What happens when I need to differentiate this? Sine inverse square root x. Wow, this is complicated, honestly. Okay, I need you all to pay close attention. Thank you. There are many layers of chain rule here. You think you can do? Just do what? If you think you can do, just carry on and work on your own. And just shut up. Okay, let's look at this. Sine inverse square root x whole thing squared. First thing we need to do is chain rule by bringing down the 2, and then you get sine inverse square root x. This is the first line. I differentiate something square, I bring the 2 down, and then it was something, 2 something. But that's not all, right? I need to differentiate this something once. Sine inverse square root x once, which is, look at formula list. Differentiate sine, you get this. Differentiate sine inverse, you get this. That means you will get a 1 over square root 1 minus square root x squared. Most of us will stop here. Most of us will stop here, but be careful. If I differentiate sine inverse x, I'll get 1 over square root 1 minus x squared. But now this is not x, this is square root x. I need to apply chain rule one last time. I need to differentiate square root x. This one is chain rule. Half x to the power of negative half. This is chain rule. Don't forget this term, please. Don't forget this term. From this point onwards, I do not care already. This is just simplification. I'll leave you all to work it out.